Hello everyone, this is episode 1 of a video tutorial series for using my GBA Toolchain kit. Toolchain? Yeah, the GBA Toolchain for developing Game Boy Advance ROMs. This will be covering how to set up VS Code for developing Game Boy Advance games. And the first thing that we need to do is actually install CMake, because the entire toolchain is CMake based. You can install CMake from the website here. That should work perfectly fine. Windows, Mac, Linux all supported. What I'm going to use is my installation of Visual Studio, which has CMake with it. So you can download and use Visual Studio. This isn't VS Code, this is Visual Studio Community Edition. But as long as you have CMake installed and working, everything will be fine. Okay, so to download the toolchain, just go github.com/my name, Felix Jones, /GBA-toolchain. Cool. Now to download a project from GitHub, we need to hit the code button here and do download zip. That'll package the entire repository in a nice little zip folder. There we go. Let's get that extracted then. Here we are in my GBA projects folder. Gonna right click on this, and I don't want to show extracted files, and we don't need a subfolder because that'll complicate things. There we go, extract. And once that's done, there we go. We can probably go ahead and delete this zip folder. We won't need this. If you have Git installed and you're comfortable with Git, you can just git clone the repo. It'll be just as fine doing it that way. If you're not familiar with Git, then the zip folder's there. Right, so now we need to make an actual project folder for the Game Boy Advance ROM itself. This won't be a game, this will just be a boring old ROM for now. There we go, GBA VS Code, we'll call it that. Yep, it's definitely an empty folder. Let's open up VS Code and open up the folder in that. I'll navigate to where my projects are. Here they are. GBA VS Code. Select this folder. Perfect. Now this won't make a code project by itself. We're using CMake, so we need to define a CMake lists file. You can imagine CMake lists.txt as like a project file these days. Multiple IDEs support it. You don't have to use VS Code for this, but I thought I might as well do this tutorial in VS Code because it's free and available for all. So to make the CMake lists.txt, just do new file here, CMake lists.txt. Perfect. Okay. I don't think VS supports CMake out of the box, so we need to install the CMake tools, which are now part of Microsoft. So we'll just search for, I don't know, CMake, I suppose. There it is, CMake tools. And we click the install on that. And this should add support for the CMake's list.txt. It should use our installed CMake, which for me would be Visual Studio. Ah yes, it's already decided to start parsing the CMake lists.txt and had some errors there. Alrighty then, let's close out of this. Okay, so first of all we need to actually activate the GBA toolchain, because this is just an empty text file, has no idea about compilers or anything. So to do this in VS Code, we need to have like a directory dedicated to VS Code settings, which is the .vs code folder. All VS Code specific stuff will be in here. We make a new file, cmake-kits.json. So the way VS Code's CMake plugin works is that it uses kits to define compilers and such. So we'll name our kit ARM GBA. Now we need to give it a toolchain file. We need to point to the GBA toolchain.cmake file, path to toolchain file. So I'll show you where that is in the directory here. If we go up from our project folder, then into the download repository, and there it is, arm-gba-toolchain.cmake. So we need this file. And then back in VS Code, I'll paste it between the quotes. Now I'm on Windows, so there's backslashes here which don't work well with JSON. arm-gba-toolchain.cmake. Now this is a CMake script which downloads everything needed, downloads the compilers required. Okay, so here's our kits. Oh, it's missing. Okay, well, you can see all my Visual Studio kits and Clang as well hanging around. Okay, so I suppose we can try quitting and reopening VS Code, see if that fixes this. Usually that does. Now back in VS Code. Oh, something's configuring down there. Oh, didn't quite catch that. Okay, so there it is, right at the bottom. So you can see that's the full path to the toolchain file that we just defined. So let's select that and loading kit. There we go. And that hasn't downloaded the dependencies quite yet. So we need to tell CMake to reconfigure itself to activate the toolchain and download all the dependencies required. Oh, here we go. You can actually see this happening in real time. So this is downloading the ARM embedded GNU tools. They're quite large. Download might take a while, so be patient. It'll take even longer to extract because there's lots of tiny files and folders that it needs to pull apart. Done. And now it pulls GBA fix source code and libtonk, which is a handy library for writing GBA ROMs. And that looks like that's everything there needed done. Cool. And I guess we can create our CMake project for real now. So let's set our minimum required CMake version. 3.0, that'll do. Okay, so there's no syntax highlighting here. Here we go. We'll just use this language support for Visual Studio Code. So this should give us syntax highlighting. Yeah, look at the bottom there, little video. Oh, there we go. Yeah, CMake minimum required is in blue. Perfect. All right. Okay, so the toolchain, GBA toolchain actually defines a CMake variable when it's working properly. It's GBA underscore toolchain. So you can use this to separate your Game Boy Advance code from any other code your game might use if it's on another platform. In CMake, yeah, you can do the hash for comments here. Let's just print out for now the status that we've found the GBA toolchain. Cool. Let's save this. Oh, that's nice. It auto-configured there. So we should be able to see at the bottom. Yeah, there we go. Found GBA toolchain. So when we saved, it auto-configured and it updated itself and then ran the script again. Cool. Okay, so let's turn this into an actual ROM. We need to define a project first of all. Just my project, I suppose. The language we'll use C. Actually C++. There we go. And we need an executable. So this is the output file that's used. My game. It's not quite going to be a game. There we go. So main.cpp is the one source file we'll have. Save that. Oh, and it's going to configure itself and find there's no main.cpp. Yeah, cannot find source file main.cpp. It's because we haven't added it yet, so we missed a step there. Yeah, look at this error here. How annoying. No source is given to target. Well, let's add the source then. We'll just give it a standard entry point for C++, which is int main arg v return 0. Go ahead and save that. And I suppose now we need to update the CMake configuration to tell it that we've just added a new source file. Yeah, it's not detected it still. And detected, nice. Cool. Let's try and build this, see what happens. Now this shouldn't work because we're missing some libraries. Yeah, there we go. So exit.c, undefined reference to underscore exit. So the GBA toolchain comes with a runtime library. So to activate it, we have this new CMake function, GBA target link runtime. And now this is added by the GBA toolchain. We'll target my game. And the runtime we want to use is for ROMs. There's also the toolchain comes with multi-boot support, so we could just type in multi-boot, and that's for GBA link cable homebrew. But that won't quite work with GBA, our emulator that I like to use, so I'm going to stick to ROM for now. Oh yes, we need to build it, don't we? Build all. Linking. Cool. Build target my game. I forgot something here. So the output for this, if you go into the build folder, there we go, my_game has no file extension. So it's not quite going to work with GBA. So to add file extension in CMake, set target properties, then the target we care about, which is my_game, properties, suffix. We'll add the extension .elf, which is embeddable linkable format. Now, GBA does support elf files. We'll just build this here. There we go, my game elf there. And we can look in the directory, there we go, my_game.elf. And it's a binary file, so can't view it right now. But then if I were to open up GBA and then drag the elf from the folder here, and we get a white screen because all we do is return 0. So I suppose we can add some code so it does something a bit more interesting. So I'm going to use code from the Tonk tutorial. It's C code, but it'll work fine in C++. So dereference a pointer to integer, and the address is 400,000 hex. And this is the register for display control. And we'll put in these bits, which is mode 3 activating background 2. Now a 16-bit short at address 600,000 hex. And this is the VRAM. We'll address this as an array, and that's 120, 80. We'll put in a red pixel because it's BGR 16, BGR 555 16 pixel format. We'll move this one across. There we go, and this one here downwards. Cool, and we'll change this from red to green, and this one here from red to blue. So this should give us a blue, green, and red pixel, and we'll loop forever because it's a game that never ends. Perfect. Let's go ahead and build this. Nice. And now open MGBA. Oh, still have the white screen from before. Well, I'll just drag this new one on top. There we go. And there's our 3 pixels. All right, hopefully that makes sense. If you have any trouble, follow me on Twitter @Xylephian and give me a little message and I'll try and help you out. Next time I'm going to show how to enable step-by-step debugging with VS Code and the MGBA GDB debugger. It makes developing GBA games 100 times easier because you can actually see what the machine is doing step by step and fix problems as you come across them. Cool. So that'll be for next time. Thanks, I suppose. Goodbye.